All right, so this one is going to be on macromolecules. So these will be the basics. We'll just talk about what those are, and then we're going to do recordings on each of the four. And I use that real loosely because it turns out one is actually not a macromolecule technically, but it is typically included in this group. Okay, so first of all, we'll talk about organic chemistry. The word organic just means carbon-based. Um, so carbon is atoms can form diverse molecules by bonding to four others. Remember, carbon is has an atomic number of 6. So 2 electrons go into that first orbital. The other 4 go into the second, and you have room for 4 more. And because of that, it will bond again with 4 different electrons sharing those electrons in covalent bonds. So usually makes up some major structures. So what we're going to do is look at how they can be put together, and we're not going to worry too much about these, but the lengths of the carbon chains can be different. They can share 2 sets of electrons with something called a double bond, and then where that double bond is, we'll give it its shape. Then you can also have branching. You can have a straight one versus a branched one. And then also you can have the presence of rings. So really what I'm trying to do with this is show you that all of these carbon skeletons are different. And what I need you to remember is shape really kind of determines function. And that's going to become important later as we talk about certain things. So that is definitely important. Shape determines function. All right, so there are isomers. In the chemistry section, we talked about isotopes, different elements that have a different number of neutrons. Well, here what we're doing with isomers are basically chains or rings that actually have the same molecular formula, but they are shaped different, which means they will act slightly different. And so there are 3 different types of structure or isomers I want you to know. One is structural, and that is difference in where the covalent bonds are. So here we have one that is straight here versus one is branched, although again, they have the same chemical formula. The second one is called cis-trans, and that name has changed. So if you have an older edition of the book, you should know cis-trans is where we want to go. I will tell you that the last couple of editions have used cis-trans, so it's not a big deal. But if you have an older book, that could be a problem. Okay, and so basically what that means is you notice we have X's here, and it is the rotation of the double bond. So here we have the 2 X's on top, where here we have one of the X's at the bottom and one on top. So these are 2 cis-trans isomers, and they will again act slightly different. And then the last one is an atomer, and these are asymmetric carbon molecules. And kind of the example of this is always given as like your left and right hand. They're not exactly the same, they're mirror images. And so that becomes important. And I want to show you an example of why this is important. So pharmacological anomers, what you're going to find out is there is a left hand and a right hand of some of these structures, and some of them are effective and some of them aren't. So here, ibuprofen, that is a pain killer. And it turns out the effective enantiomer is the left-handed one, and the ineffective is the right-handed. So when I am a pharmaceutical company, obviously I want to make, I get both, but I want to have the left-handed one. Albuterol is used for asthma. It opens up the airways. And again, just to show you, the effective one this time is the right-handed one, whereas the left-handed one is ineffective. So again, when I'm making it, the problem is I'm getting both, but I want the right-handed. Just to take this a step farther, what you can get is we've got something like L-DOPA. I don't know if you've heard of L-DOPA, but it's used for Parkinson's disease. That is what Michael J. Fox has now. And basically it's where the body involuntarily shakes, losing control. And then the left one is effective, the right one is inactive. And just to see, and I usually ask the class, it's kind of hard to do on a video, but the movie that actually had L-DOPA in it with Robin Williams, which is a good movie, it's a true story, was Awakenings. And there are people who are kind of living statues. He was a psychiatrist working in a hospital, Robin Williams did not get along with people real well. And so he had seen a talk on Parkinson's disease and L-DOPA. And what he thought is these people had these tics, these things where they would shake and then they turn in on themselves, and then they became these living statues. He gave them L-DOPA, large doses, and they actually woke up. And the scary thing is they said that they could hear everything going around them. You could get them to do things if you started them to do it, but they had no drive to do it on their own. So if you have never seen the movie, good movie, so Awakenings, L-DOPA. Let's take it a step further. Thalidomide is another one, and you can see if you look at this picture, we have children with birth defects. And this was actually prescribed to women with nausea. It actually reduces nausea. The problem is, again, this left and right idea, but what happened is this obviously caused birth defects. So it was discontinued. It is now being brought back, which is, I guess, could be scary. But it's being brought back as a cancer drug. It actually does stop nausea extremely well. But major warnings, obviously, you cannot be taking this if you are going to be, if you are pregnant, chance of being pregnant or thinking about being pregnant. And so it is back on the list of things that are being prescribed, but only under certain conditions. And again, a lot of times the form follows function. You can see here two very similar molecules. These are both steroids, and these are the kind of the sex hormones. Estradiol or estrogen is the female hormone, and testosterone is the male hormone. But again, they have a very similar shape and structure. Okay, the last thing I'm going to need you to know, and this is another one that you got to be careful. The older editions, again, I think last edition was like this, but the one before wasn't. Functional groups, and here you have 7 of them. And I want you to be able to recognize them. Okay, so you need to know the names. This is the chemical groups here on the left: hydroxyl group, carbonyl group, carboxyl group, and amino group, sulfidyl group, phosphate, and methyl. Methyl group is the one that could be missing. All right, you need to know the compound names, which is these down in the middle here. What you don't need to recognize is ethanol. If I gave you this molecule, you would have to tell me it is an alcohol, and you'd have to be able to tell me that this is the hydroxyl group. Here, this is a carbonyl group. You don't have to tell me this is acetone. But you will have to know that it is a ketone, and that's where there's a C with a double bonded O in the middle. And then here you're going to notice over here on the right, there's a C double bonded O with an H. This grouping here is called an aldehyde. Okay, so it's called an aldehyde. And so you need to know that. Notice the carboxyl group is very similar. Instead of having just the C double bonded O on the bottom here, instead of the H, they actually have an OH. So a tad bit different. And again, so you need to know the chemical groups, you need to know the compound names, and then you need to be able to recognize, if I gave you a molecule, what kind of functional groups are on the end and what is its compound. All right, and then we're going to do one last slide. Couple of different terms on here. We have monomers. Monomers, those are single units. That's the basic unit. And then we have polymers, which is basically a bunch of monomers attached together. So here's what I need you to know. To put molecules together, we have a process, and I need you to know the name of that process. The problem is there are multiple names for the same thing. So the book now is using dehydration reaction. That is when you take a monomer or a short polymer and you hook on another monomer. You can see that the H on one side, the OH on another actually forms water, gets pulled out and forms the bond. So dehydration, the loss of water reaction to make it react. So that's one name. Dehydration synthesis is another name. And then the third name is condensation reaction. So I've seen all three of those, so I'm going to hold you to all three. If I ask you, what is it called, you can give me any one of the three that would be correct. But on like a multiple choice test, if I had used only one of those, you'd have to be able to find it. So again, dehydration reaction, dehydration synthesis, condensation reaction. The good news is the opposite one. Down here, when you're going to take a long polymer and break it, you are adding water, and that is called hydrolysis. Hydro means water, lys means to break, breaking with water. And there's only one term as far as I know for that. So that is the good news. So again, making monomers into polymers, we're using dehydration synthesis, dehydration reaction, condensation reaction, and then to break polymer into monomers, we are using something called hydrolysis.